In the previous lessons, we talked about the systems in place and how you could recognize waste, and how with the LandMentor technology we can change the way communication is with the plan to not only recognize the waste but communicate that in a way that something can be done with it. In these next two lessons, we're going to talk about connectivity. Well, the grid is assumed to provide pedestrian connectivity, but does it really? So we're going to explore that. So when we look at the grid and look at it from a pedestrian connectivity viewpoint, I actually happen to live in a grid neighborhood. I live in St. Louis Park, Minnesota, and what's thought is this closest distance between 2 points is a straight line, which is true. So if I want to go from my house to the park, straight line distance, I could be at the park. I have 2 restaurants within walking distance of me. I cannot walk directly from point A to B. I have to walk around the grid, and I'll go a half a mile to 2/3 of a mile out of my way to get to those 2 restaurants. So guess what? I am going to drive because of the grid. So the grid does get you the closest distance, but only if you live on or near that street. As soon as you start skewing across the grid to get to your destination, not only is it a much longer distance, but then you've got a lot of vehicular and pedestrian conflicts, and that is a huge problem. So again, it's about thinking differently, and the way to think differently is instead of having the walks simply as a byproduct of the streets, why not design the pedestrian system first? And I'll show you how this works. This was the before plan, a modified grid of Viera, Transona, Viera, Florida. The existing retail commercials at the upper right corner. There's future retails to the right, existing homes to the upper side, and future homes to the south. The 2 main east-west streets and north-south streets that bisect this into 4 different neighborhoods had to have similar connection points, and they had to stay. So the first thing that we did was draw the main trails, and we did it in a way that would lead people directly to the retail. It was a flat site, so I like straight trails and flat sites skewed across the site, so you could plant a small tree each side of that trail, and 10, 20 years later becomes a tree-lined trail, very cheap to do, and sustainable as far as being usable and attractive. But the main thing is we had a large circular walk that bound those 4 different quadrants together to create a cohesive neighborhood. You cannot do that with a street system. You can only do that by designing the main trails first. And then we designed the streets and minor walks around that main trail. And we'll get more into the street design later. But what we want to do is have the main trails define the neighborhood, and then supplement that with elegant and wider than minimums, so they're usable walks to be very attractive and invite a stroll. And the picture on the left is in the Lake of the Isles area of Minneapolis. That's 100 years old. Look at that nice 6-foot wide inviting meandering walk and the meandering setbacks. And this is one of the most stable real estate prices in Minnesota, and very high values, and somehow it got designed 100 years ago, and it still is desirable today. It's sustainable. So when a main trail crosses a street that has some traffic load, we'll put a diffuser. What a diffuser is a island that separates vehicular and or pedestrian traffic. In this case, it's pointing to a trail crossing a street that does have some traffic load, and that way as a person is driving, they will see an island in front of them, they'll pay attention, and then the pedestrians or bicyclists, they cross at one ways. The other thing we do is we pull walks away from the intersection. When you put walks at the intersection, what happens is a driver is looking for other cars. They're looking, your mind zeroes in on the most dangerous thing, which is a car coming at you, not a pedestrian coming at you. So the worst place you could put walks is at the intersection. The best place is to pull away, and the meandering walks allow you to do that. It's much safer. So some of the minimums, again, are based on state, federal, and local standards. And again, we're talking about minimums that are in the ordinance. None of the existing regulations factor in the future. What if someone comes up with a better idea? So keep that in mind. Keep that in mind. They factor the past, not the future. Narrow walks, for example, in the U.S., 4-foot walks, they're not wide enough. They're standard, but they're not wide enough for couples to walk side by side. So guess what? They walk in the street. Why even have the walks if people are going to be using the streets? 5 foot or wider allow couples and people with children to comfortably walk side by side, and that should be a minimum. But you should size the walk to the traffic load. Wider walks even can be used for emergency vehicles. So a lot of streets are built for emergency vehicle circulation. Why build streets if a walk will do, and if you don't need the street? So the question is how the developer is going to pay for all of this, and that will be answered as these lessons go on. So think differently. There are no existing regulations, and you'll see that, and I will prove this, in suburban design, and I think even in urban design, that really addresses vehicular flow. And to explain that, it's a concept that is taught in LandMentor. Neighborhoods that maintain flow are going to be more marketable than those that don't. That's an important factor, because desirability is equal to sustainability, because every time the next generation moves into that neighborhood, it has to be desirable. It has to compete against other neighborhoods. So it's very, very important. So why is Isaac Newton so important? Well, he stated a body in motion tends to stay in motion. And that body is a car. And a car is hard to get going, and it uses a lot of energy to get that car going. So under normal driving conditions at 25 miles an hour, which is U.S. residential speed, it'll take 200 feet, or something like 66 meters, to get that car up to cruise speed, normal driving, and another 200 feet to come to a stop. So that is 400 foot where you're incredibly inefficient. After that, you're very efficient. We call that 400 foot a flow cycle. So the minimum flow cycles, the more efficient the neighborhood. And that's again where grid fails, because someone's got to stop at that four-way intersection. But when you start looking at a suburban design that you think is efficient, and then you start saying, wait a second, look at all that one-sided frontage, maybe it's not so efficient, but we're not talking about geometry as we did before. We're talking about vehicular connectivity and flow. So let's take a look at that for flow. If you lived in that location, you are never even getting close to 400 feet at any segment to get home, but you have multiple segments. Assuming that you are going to stop at least for a second or two to take a look to see if a car or a pedestrian's in front of you at that intersection, your average mile an hour will plummet from about 25, which was the goal, and the speed limit here, to about 7 to 8 miles an hour. And that's pretty pitiful. So what happens is you're going to hit that gas a little harder and the brake a little bit harder. So most residents have to have multiple flow cycles to get home. Now, on the replan, some interesting things happen. Notice how little street is built without frontage. But then notice how the homes pull back away from the street. We actually have more than 100% efficiency on these streets. But we'll get into that later. What we want to do in a neighborhood is not only maintain flow, but have a main street identity, so that when you enter that neighborhood, that street identifies that neighborhood. So we don't want a lot of multiple disconnected streets. you enter and you're maintaining flow, the time and energy will literally plummet in this neighborhood. Now, we had a 33% reduction in street length. That equated, by the way, we did run the numbers on this, $300,000 less in construction cost. But most homes were at premium settings compared to where they were before. There were $600,000 increase in lot premiums. So it was almost $1 million advantage to the developer. And it's the same density. Both of those plans had 136 units. So, what's in it for the city? Well, the city has 33% reduction in street length, which means that's a public street, which means they have a much higher tax base because $600,000 more in value goes right into the tax values, and they have 1/3 of the street to maintain. But the big thing we're talking about here is not all those benefits, but people who live in the neighborhood, it's going to look better, it's going to feel better, it's going to be more open because you have less street, less right-of-way. But the big thing is you're going to get home, to and from home, with a whole lot less time and a whole lot less energy. So, anyhow, what happens is that's starting to tell you what pays for all of this, almost $1 million advantage over 136 lots. And we'll get into that later. And you think this is an American problem, something like that? Well, these are pictures that we took, or plans that have come in from around the world. I went to Jeddah and Riyadh, and I was actually in the governor, His Highness Al Duba, and he took me in his jet between these two cities, and I took these pictures out the window. So this is the planning of Saudi Arabia. And Saudi Arabia, these are wealthy neighborhoods, but look at all the time and energy. So if you think that I'm talking about U.S. suburban development and a lack of thought process and a lack of attention to detail, look, I'm going to show you around the world. This is not an American problem. This is a world problem. And if you're a student in the industry that is looking to solve these world problems, and for example, this is King Abdallah Economic City along the golf course. This is a maze to get around. This is a very inefficient plan. And it's done by one of the top engineering and planning firms in the world. And this is what they come up with. This is a huge problem. This is about 40% excess pavement. You have lots that are limited along the golf course. The other lots will never know there's a golf course there, and there's no walking connectivity. So this isn't a problem of American suburbs. This is a new development being proposed in Johannesburg, South Africa. Again, the same thing. A maze, zero attention to walking ability, does not take advantage of the views off of the topography. India, need I explain more? Wow, Mexico. This took a big effort. Look at the volume of pavement versus a tiny little itsy-bitsy lots. Panama City, Panama. We're doing a lot of work in Panama City. So this is walkability. This is obviously drivability with straight line, but you're not looking at all the cross streets. This is how the world grows. As a student in engineering, surveying, planning, urban planning, land planning, architecture, you have the ability with this training and this technology that we are providing to you to think differently and make a significant change in the world, because this isn't a neighborhood that's sustainable. I mean, it's a brand new neighborhood and it already looks bad. So, the concluding thoughts for these lessons is the regulatory process ignores connectivity. The only option's been the grid, and that's not as connective as we could be if we think differently. We need to separate vehicular and pedestrian systems if we're going to create a safer world. And having walks parallel to the curb is a button press, a CAD is not enough. let's take a look at that as a separate system and give it some design and some desirability and some function. Geometric simplicity, and this is what we're going to talk about next, it destroys neighborhood character, and it actually destroys neighborhood function, but even bigger, it destroys the value of the neighborhood. And these systems have not changed at all for centuries. There were no cars 120 years ago. There was horses and oxen and carts, and speed limits were a train doing 20 miles an hour or 30 miles an hour along tracks. That was the world's transportation systems, and yet we're still designing almost the exact same. So we need to look at these systems with far more effort than putting it into a system that we could design the neighborhood in 120 seconds flat. And that is the main goal of LandMentor, is to empower you as a student to go beyond your education and be a leader in this world to truly make a difference. The next lessons are going to talk about geometry of the past and how we can use LandMentor to create a new era of geometry, and geometry controls possibility. Thank you.